Hello and welcome to our Tips and Techniques videos. I'm Mark Biasotti and we are currently in our advanced modeling episodes. And over the next 30 minutes or so, we'll be exploring how you can increase your skills using some of SolidWorks' more advanced features so that you can be more productive and create higher quality models. So whether you're a seasoned SolidWorks user or a beginner, we think that you'll learn something new in this series. For your convenience, we've listed the topics in the YouTube description that we'll be covering in today's episode, along with a timestamp for each topic in the video. Feel free to skip ahead to any tip or point you want to learn more about. This series is being brought to you by Spanner Product Development, a product development company dedicated to creating positive impact in the world, merging innovation, sustainability, and responsibility to bring meaningful experiences to life for over hundreds of clients. If you want to learn more about what Spanner has to offer, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Now let's get started with this episode of our Advanced Modeling episodes. Welcome to our SolidWorks Advanced Tips and Techniques video series. This is Advanced Modeling Part 2, Working with Curves. Over the next 30 minutes or so, I want to introduce you to curves in SolidWorks and talk about some of the various aspects of them that will help you to create quality curves and therefore create quality surfaces and advanced modeling. One of the reasons that curves is one of my favorite subjects to talk about is that I have a mantra that I've spoken about many times before. That is that surfaces are only as good as their underlying curves. And what I mean by that is that for most advanced modeling or surfacing, it is comprised of curves. The curves are the underpinnings of that surface. If you don't get the curves right, the surfaces won't be right. So it's really important to start our advanced modeling series at this point talking about curves, and then later on we'll talk about the surfaces. We need to get the curves right and learn about how to create good curves before we can go on and apply them to creating great surfaces. So with SolidWorks, there are a number of curve types that you can create. You're probably familiar with some of the more basic types, which are Thru-Point 2D Sketch Spline. But you might not realize that there's many additional ways that you can create curves in SolidWorks. So I'm going to step you through those using a live model as an example to show you how many different types you can do in SolidWorks. And this list right here is not exhaustive. There are other curve types, but I thought I'd hit on some of the more useful and popular types and walk you through these. So of course there is 2D Thru-Point sketch splines that you can create in a 2D sketch. Starting with SolidWorks 2.14, you can create Style Splines, which are just a higher quality spline than Thru-Point Spline. Important to industrial designers. We'll get into that a little bit more. I've also listed conics as a curve type because I find they can be very useful for doing bridge curves, for doing corners, for doing things that Thru-Point Spline can do, but with much better parametric control. And then of course, one of the great things about SolidWorks is that it has a 3D sketch functionality, and Thru-Point and Style Spline can also be used in 3D sketch as a 3D Thru-Point spline or a 3D Style Spline. The exception to that is for the current release of SolidWorks conics, you can still not do those in 3D. They're confined to 2D. We're hoping for the future that they would be available for 3D because that would be a nice feature to have. There's also different ways that you can create curves using existing geometry. So we have the intersection curve, which is basically a curve created from two existing elements, whether they be two intersecting surfaces or whether you're in a 2D sketch and you have a model face or surface penetrating that current 2D sketch plane. And I'll show you how to do these also in our example. You have the split line curve, which is basically creating a sketch and then splitting faces of your model or surface to change the topology. So there would be a model edge in that surface after splitting it with a 2D sketch curve. You can project sketch curves onto your model by creating a 2D sketch and then projecting it in a direction of normal to the sketch plane onto a model face or surface. You can also build two sketches that are opposed by 90 degrees, for instance. Say you create a spline in the top view and you create a spline in the front view. You can then take those two sketches and combine them into a 3D curve using this function of projecting by two curves. You can also take into a sketch, you can convert entities from your model into the 2D sketch, both in a 2D sketch and in 3D. You can offset or convert those, and that is a curve type in itself. You also have spline on surface, which is a special through-point spline that you draw continuously on a surface. What I mean by that is as you draw, it's constantly constraining itself to the face that you're currently drawing on, but whether it's a surface or a solid face. You have fit spline, which in itself is creating a new type of curve where you can combine different sketch elements into a single spline. It in essence fits the spline over multiple entities. And that's very useful if you're needing to create a feature that calls for or requires a single spline element to make a higher quality surface. I'll get into more of that later in the episode. You also have, starting I think with 217, 218, the ability to convert a through-point spline to a style spline and vice versa. And that can be very helpful because some people have an aversion to creating a style spline because of the control cage. You now have the best of both worlds. You can create a spline how you've always been used to doing that and then just simply convert it to style spline for higher quality. And then you have the ability to take, for instance, imported curves or convert edge curves or offset curves and simplify them, meaning you can modify them to simplify their degrees, free them up, delete constraints, and it's a way of taking existing curve geometry and further manipulating it. So with that, let's get into our example model. Okay, we're going to start with this model that I created to exemplify many of the different kind of curves that you can create in SolidWorks. And this is actually made up of a number of curves. You can see in the feature manager here, we have all kinds of things, 2D and 3D, through-point curves, style splines, fit spline. You even have a split line here. We'll be able to show how you do a lot of different types here. So let me, instead of just rolling through the tree and showing you what I created, let's start from scratch, because I think that's where both you and I will both learn a lot as we walk through it, and I can recreate it as we go. So let's turn our planes on and go back into our default view. And I've created one plane back here. Let's start in this front plane. We're going to create four bounding curves for a boundary surface. So we're going to start on the front plane and start to introduce you to the most basic types, which is a through-point spline. So here I've just done a 2-point through-point spline, and it looks like a line. It's really not. If you click it, you can take and drag up the angle controls. These are the magnitude controls, which control the amount of magnitude from the vertices. And I generally will not create anything more than a 2-point spline. If it's 3 points or better, I'll probably create a style spline. The reason being is that this is traditionally a B spline. But if we were to introduce a new spline point in it, and then turn on our curvature, initially it looks really good. But as you start to move it around, you get some, I wouldn't say, there isn't curve continuous, and it's not even not C3, but you start to, as you start to manipulate these interim vertices, you get some discontinuity or some undesirable effects. So if you are going to do 3-point through splines, it's best to, in the interim curves, to hold down your Alt key. And by holding down the Alt key, you're able to drag these symmetrically around that interim vertice. And you're going to get the best result that way. If I let go of my Alt key and I start to drag these individually, you see what happens? You get something that doesn't look quite nice and is not a desirable effect. And that's because under the covers of this B-spline is actually 2 splines connected. And they're doing their best to control it, but with a style spline, it's quite a different story, because a style spline that was introduced in 2014, I believe, is a different technology called Bezier spline, or Bezier. Can never get the name right. And what it is, it's a single spline entity, but with control. This control cage or control polygons allow you to manipulate the spline to get the shape you want, but keeps very good continuity throughout the entire spline. So that's just really a brief introduction of something that I'll cover later when we talk about the differences. So here we have our Thru-Point Spline. Let's constrain it. And yes, splines can be fully constrained. So I'm going to do a few things here. I'm going to make symmetry between these, and then throw a dimension in here, something like 4, and then start to dimension some of these other controls. So the angle control can be dimensioned by touching on the angle arrow and then its reference, and do the same here. I can make an equation with this one if I wanted to keep them symmetrical. And then you can also control the magnitude. But let's first bring them down to something that I want that's close. And then dimensioning the magnitude. And by the way, these are not real dimensions. They're more of a placeholder. That's not really 5 inches, as you can see. But they are a way to control and fully constrain the spline. You can see now it's black, it's fully constrained. I also like to have in my system options the control handles on for Thru-Point Spline, because I find it easier to pull on these control vertices than sometimes in other ways, traditional ways. So there's our first Thru-Point Spline in 2D. So back in this other plane that I created, I'm going to create a new curve, and this time I'm just going to do a convert entities on this existing one. So now I've done that. Anything I change here obviously will update here because it's converted indice with constraint. And that's really my design intent. I want these two curves to always remain the same. So I have those. Now let's move on to our second direction that we want to create for our boundary surface. And this time I'm going to use 3D Sketch. So in 3D Sketch, it does not require a plane. You can draw in 3D. But there are some very important nuances when drawing in 3D, and especially splines. So I'm going to create a new spline from this point to this point, maybe put an interim point in here for control. So if I click down on here, you notice immediately you get this little 2D sketch triad. And what that's doing is it's giving you a help and a help to what direction or what vector you're going to draw in. I actually want to draw in the YZ vector. So by tabbing, hitting my tab key on my keyboard, I've just changed it to YZ. And now when I draw, I get something that's rather predictable. You see that? If I just ignored that by starting here and maybe in this vector, but I thought I was drawing back to my Z, I'm going to get something like this. Because what it was doing is it was saying, oh, your general direction wants to be in the XY. So I'm going to place that point here. But really in 3D space, it's not where I expected it to be. So it's always important to keep in mind that in 3D, that 2D triad for creating geometry. Okay, so let's just eliminate, well, let's maybe move this. And if you are going to have 3 points, a really great way to do that is to use the sketch triad. And so I've just pre-selected that point. When you pre-select a point, the triad will pop up on that selected point. And now I can predictably kind of move this in 3D space. So it's a great way to work, right? So I can even kind of move this off, or I can move it this way, kind of line it up vertically. If I were to look in this view, I could do that to line it up. Okay. So that's our first curve in our second direction. The second curve I'm going to create over here, and just for the purposes of example, I'll use a little bit more control. And this time I'm going to pre-select my right plane and this vertice, and I'm going to click on my 3D sketch plane. Okay, it didn't like that. I'm not sure why. Let's try to just pick that and then pick this point, and it works. I'm not sure why that didn't work. But in any case, what I want is I want a 2D plane to sketch on in my existing 3D sketch, because I want a little bit more control. So why this plane is active in my 3D sketch, I'm going to create, and then this time I don't have to worry about the little sketch triad because I know I'm sketching on this plane. And it becomes very predictable, right? And you can even see the plane kind of updates to your geometry. There. So, you know, I can even go into this view, kind of match this, even though I really don't want to constrain it. And that's a very powerful way to work in 3D Sketch to give you a little bit more control, is to use the 3D Sketch plane. Okay, so with that, we have some curves, and we have 4 of them. And with 4 of them, let me turn off the curves there, we can create a boundary surface. So let's go ahead and create a boundary surface. So we're going to pick this as my first curve, first direction, second curve, first direction, move down to directional curve 2, pick this as my first curve in my second direction. It automatically brings up the selection manager because I have more than one curve in this 3D sketch. So it needs to recognize which one do you really want. And then I can go and pick the next one. And with that, I've got my first surface. Okay. So with that, let's move on to a couple more curve types. So on my top plane here, I'm going to create a split line on this surface. So in that top sketch, I'm just going to do an offset. So this is another curve type. Reverse the offset, make it about 0.4 inches, and then accept. And with that, I can create a split line immediately from this 2D sketch by picking this face and then creating that split line. And again, this is a new curve type. It's special because what I'm doing is I'm splitting an existing topology into two pieces, the middle and the outside here, by using that sketch. But that is an actual curve, and if I wanted to, I could actually take these by pre-selecting them and go right into 3D Sketch, right into Convert Entities. And so now I've actually made a Convert Entities from the split line. But I think we're getting kind of ahead of ourselves here. So we'll get that covered in a bit more. So we have a split line here. What I really want, though, is to actually not split it. Let's actually create an extruded surface from that sketch and draw it up over that and show you a couple other curve types. So another curve type would be intersection curve. Now, intersection curve can happen in 2D and 3D. I'm going to try 3D here. If I pick my intersection curve, it wants at least two entities. And I can pick this surface, but I can also just pick individual surfaces and create a intersection curve. And that did it right there. Actually, what I want to do, though, is I want to have a four-sided intersection curve. So it just comes through being a little bit smarter about selection. So I'm going to go back to intersection curve in 3D, right here. I'll pick this guy, but instead of picking on the screen, I'm just going to select my bodies, my surface bodies, that is. And so now, by picking the surface bodies, anywhere they two intersect, I get an intersection curve. Okay? So that's intersection curve, and we'll probably talk a lot more about that when we're starting to create some interim curves in here. I'm going to undo that, and in this example, let's go ahead and let's just split this, or I'm sorry, trim this face. So I'm going to do a standard trim. I'm going to use this guy as the trim tool, and I'm going to keep the outside of this. Let's hide this body. So I just trimmed that with a big hole in it, and now I'm going to create some more curves. So let's go ahead and just create some new reference planes. I believe, click and drag. So I could create multiple here if I wanted to by doing this, but sometimes I find this is harder to do. So let me do that, but let me just complete what I said. So I'm going to create 3 planes there, and then start to create some new bridge curves to create an inner surface. So on plane 5, I'll start a new sketch and a new curve. And immediately what I do when I'm building what I call bridge curves is I'll use the intersection curve to get some references. So I'm picking this outside existing face and laying down this intersection curve only as reference. So that's why I go immediately to construction, and now I can create my Thru-Point Spline. And remember, I don't like to use 3 points, so I'll just drag these up, make tangency here, and tangency here. Okay. And new with 2020, SolidWorks 2020, you can add G3, which is a higher order of continuity. And we can do it here too. Okay. And sometimes that'll over-constrain. I'll show you how to get around that. Anyway, there's a G3 curve. Let's move on. Let's go to the back one here. And this time, again, we always kind of start with intersection curve. Go immediately to construction. And let me turn my planes off here, just so it's a little clearer. And I'm going to do a style spline. So I'm going to drag my points out. Again, let's just do G3 right here. And let's do G3 right here. Okay, we got lucky. It didn't over-constrain. But it could, and if it does, remember to go and raise the degree of your curve if you're over-constraining from the constraints that you apply to it. So there we have our next curve. Let's move on. Let's show our planes again. So we're going to go to this middle plane. And again, we're going to do a intersection curve as reference. Make a construction. Use my H key just to hide everything. And let's do, what do we want to do here? Let's do another style spline. So again, let me show this example on this. So if we make this G3 like we did our other curves and made this G3, it's going to over-constrain. But remember, that's because there's not enough degrees of freedom in the curve. So I've just added 2 more degrees of freedom in it, and now we can get something that we can control a little better if we want to raise, this up a bit. It's still very confined because of the G3 that's forced at either ends, and you might have to degree raise it even more to get something that is more controllable. So I want to raise up these middle points. You can also manipulate these by themselves, although they're not as controllable. Okay, that's getting kind of funky. I might want to downgrade the degree of freedom on that. Okay. So let's go ahead and show what we've got so far. So we've got some interim bridge curves. I'm going to create one more through this plane here. And again, let's just do a style spline on this. And again, we'll pick this outer surface and do our intersection curve for reference. Make a construction. And then start to sketch our style spline. So I'm going to kind of sketch this out so I get my curve close to where these curves are, and I'm going to show you something really cool with the style spline. The next kind of method here is to constrain your endpoints and then work on all the other stuff. So if I start working on these curves a little bit more, let's put a little more degree of freedom in that. That's what I'm doing here by raising these up. And you can see I'm trying to get them close to these curves that are going to pierce through our sketch here. What's really cool about the style spline is you can actually control it through points. So what I mean there is that if I were, let me add one more degree of freedom here. Okay, and what I'm doing is just trying to get these close to where they're intersecting. And what I mean by that is I'm just going to use a sketch point and constrain it to the style spline. And I'm going to do that individually for each one of these that pierces through. So with that, I can take that and control select this and make a pierce. And what it's doing now is it's taking the style spline and all its advantages, but it's constraining it to those existing splines. Let me do the same here. And do a pierce. And let me do the same here. Let's place a point and then pierce it. Okay, so now we have a style spline with all of its smoothness, and we can do a little more tweaking like right there, but it's actually constrained to those existing points like a through-point spline would be. Okay, so now we have something that we can work with, and we might want to go back to this spline and, like I had done, put a little bit more degree of freedom in it, and kind of raise this up. It gets a little difficult to do without constraining these points. And of course, one of the other advantages of doing style splines is I can dimension these points to start to control this a little bit better. But I don't think we have time to go into that. So you can see that this curve has followed now, right? And I probably just want, in real life, I would tweak this a bit to get something that's a little bit more continuous across there and across here. So I'm just pulling these out a bit more, okay? And that curve is probably just a little low. I'd lift that up. But for the sake of example, let's just take this and create our second boundary. So again, I'm going first, this edge is my first curve. And I have my selection manager pinned by example, because most of these I'll just click and accept. And then go down to my second direction, which will be this edge, this middle curve, and then this edge. And of course, I probably want to draw a tangency on the 4 boundaries. So I'll go ahead and do that. I can do that in the feature manager here too. Either way, that's the interim curve, so that doesn't have any means to do that. And there we have it. So that's probably all I have time for in this episode. In the next episode, we'll pick it up again and talk about more of the nuances of these curves, how to constrain them, how to control them, get into a few more of the types. And so I'll see you back over there in the next episode.
Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to better use some of SolidWorks' advanced features. You'll see in the YouTube description a link to example models used in today's video. Feel free to download it, and you can explore these techniques at your own leisure. Also, we'd love to hear from you, so consider emailing me at the address you see here on the screen. If you need help on your design project or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care, and I'll see you in the next episode.